Alright everyone, in this second part, the second SolidWorks Baby Steps video, now is when we're actually going to start working with SolidWorks. Now obviously the first video, if you watched it, I went through a whole bunch of explanatory, introductory kind of stuff. I'm gonna save you the bullshit right now and we'll just jump into the actual work. To make a new part in SolidWorks, typically you go up here to the toolbar and you click the new page icon and then click part. This is pretty self-explanatory. Once you know where the button is, you only need to know it once. Now typically every model starts with sketch. In fact, I don't know a way where that isn't the case. So what we're going to do is we're basically going to create a rounded rectangle, roughly 5 by 5. So grab the line tool, go to the top plane, and then typically what I do is I come up here to the view orientation box and we'll put it at the top. Again, I'm trying to cover a lot of bases that I feel that a lot of other SolidWorks videos don't. I feel like a lot of other SolidWorks videos just kind of assume you're going to know what you're doing, so they kind of just leave you out of the actual process, which is fine if you do and if you just need a refresher, but it's bound to frustrate a lot of people. And just draw a square that's roughly 5 by 5. It's important to note that once you click to initially set the line, you can then adjust it by typing a measurement in on the numpad. You'll notice how this in the parameters key in the parameters box is highlighted. That's the length. The parameters tool section is actually pretty useful. Namely because you can type in fractions, so if I tell it 1/16, it will automatically convert that to 0.0625 of an inch. I can also type in units that are not congruent with my current unit system, because right now I have it in IPS units, inch, pound, second, that kind of thing. But if I want to tell it to just, go if I want to tell it to make me a line at 4 millimeters, it will do that for me. Now what we're going to do is we're going to round off the edges of this rectangle, which is why I haven't drawn in any of these solid lines yet. These are just centering guidelines. And that's what you should get in the habit of doing. It's kind of like fencing your workplace in the sketch area with these lines. I mean, once you get better at doing it, you can become much more renegade about how exactly you do it. But just as a rule of thumb, I'd recommend fencing all your stuff. I mean, you'll thank yourself when the results come out pretty. That's basically how I always see it. Now, here's the point where we actually start drawing something. Go up to center point arc, click the center of the arc. I'm centering it so that the turn radius of this corner will be 1/8 of an inch. To do a center point arc, you typically first click the center, then you click the radius at the angle you want to start. So okay, 0.125, but I'm starting vertically, so I'm starting ideally at 0. And then you ideally drag to the end point. You'll notice right there that SolidWorks can sometimes do funny things like invert the circle, where it will assume you're wanting the other section of a circle than you actually want. It just takes a little bit of fiddling to get it to figure out what you really want. Now what we'll do is we'll delete these guides. So now we're left with 4 quarter turn arcs. Just connect these real fast. You'll notice that you can see the smart dimension tool button up here. Smart dimension places a dimension on the sketch. I mean, a lot of these SolidWorks tutorials that are actually embedded within SolidWorks, so okay, if you go help SolidWorks tutorials, a lot of those tend to make you put the dimensions on every sketch as you do the sketch. I typically get lazy about this because you can always add them in part drawings. And when you do part drawings, you can always make up for places you got lazy. So I typically leave them out. I mean, it just boils down to a matter of personal preference. So okay, here's the completed sketch shape. You'll notice that we have basically a rounded rectangle. And there's most likely easier ways of doing that, but I took you through the long way just to, well, show you how to do it manually. And that's the important thing is, well, a big portion of learning CAD is learning the techniques, the tricks, the finesse of CAD. You do still have to learn things the hard way, because if the tricks don't work for any reason, you still need to be able to do certain key processes. Now click Exit SketchUp here. You'll see that it turns back into the normal sketch button. Click on Features and Extrude the base. In 1 second here. You'll notice there's 2 extrude options that you'll see primarily. There's Extruded Boss and Base, and over here there's Extruded Cut. Obviously Extruded Cut is grayed out. Extruding a boss or a base will essentially pop something out. So we'll take 2D and make it into 3D. It'll make a 3D object from a 2D sketch. Whereas Extruded Cut will take a 2D sketch and it will punch it through an already 3D structure. So then generally just go about 1 inch. I mean, I'm not being, very tight on the dimensions here, but we're building an example object. How tight of the dimensions do we have to be? 1 inch high, click it, and almost instantaneously you'll see them all solidify. So here's what we're dealing with so far, and if you've made it this far, go ahead and congratulate yourself because you've officially made your first 3D model. Now what we need to do is we need to create the main peg. Essentially what this design is it's a square with a big bolt hole coming out the top. With a bossed out bolt hole coming out the top. And this isn't just for, shits and giggles. This is the circle and square test typically has relevance in CNC machine circles because of the ways CNC machines handle circles. CNC machines typically handle circles by interpolation, so they spin their motors around and they control the feed rate and the advance rate of the motors to generate the circle, where the slope and the rate of motor movement is based on where in the circle the tool head is. The circle and square test versus circle, diamond, square test, they've been used sort of as a reference to test the accuracy of the CNC mill. Now, of course, we're not really designing a test like that right now. I'm just trying to get you all past the basics, but there's some background. And we can go ahead and add a diamond to it. You'll notice that SolidWorks tends to keep the center lines in place. Exit sketch, and then we'll extrude this boss upwards. So now you can start to really see how SolidWorks works. Basically, what you're doing is you're sketching on top of something. So first you were sketching on top of the base plane, then you extruded the model up, then you sketched on top of the model. Once you had that sketch, you bossed it out again. And now we're going to draw a circle. Guess what? On top of the second sketch. So just do something like that. Again, the dimensions for this don't really matter. It's designed to really get you just starting to create, and a large part of starting to work in new things is unfortunately just brute force and repetition. So we've extruded 3 times, so you're probably already familiar with pretty much what Extrude does. I mean, the extruding bosses and bases and stuff like that. And now it's time to actually do some cutting. To do some actual negative material work. Because so far what we've done is we've done additive processes. And I use that term kind of in the same way that 3D printing uses that term. We've built up a model, but at some point you're going to have to cut it down. And that's what the extruded cut does. So we'll go back to sketch, and we'll just draw a circle on it and make it a radius of ½ an inch, so it's an inch diameter. Exit the sketch, and then extrude the cut. Now, one thing I haven't explained so far in the extruding options is that you see this direction, and you'll see this list of essentially components or parameters, or conditions, if you will. You'll see blind, through all, both, up to next, up to vertex, up to surface, blah blah blah. What blind means is that blind will punch the hole or boss the face up to the distance you tell it to. It will do it just as it says, blindly. It won't autocorrect for you if you don't know the proper distances. Whereas true all will correct, and what true all will do is it'll go ahead and find out the entire width of the material that the cutter boss is supposed to be going through, and it will automatically take care of that. Then you have stuff like up to surface, which is for when essentially up to surface is when you're trying to punch a bolt hole through, for example, and you want the bolt hole to, or you want the boss to go up to the face. Trying to think of a good example of how to explain this that doesn't sound like a bunch of garbled up nonsense. Suppose you have a hemisphere and you want to put 6 cones going into the top, but you want 6 cylinders going into the top, but you want them to only stop at the top surface of that hemisphere. You would select up to surface and then click the surface of the hemisphere, and then they would automatically stop there. In fact, it's kind of interesting I picked that example because we're going to be working with that exact kind of design later on. I had that planned out. So, once again, just to tidy this thing up, what we're going to do is we're going to punch a bunch of bolt holes through this thing. Again, go sketch, center line. And what we're going to do is we're just going to be extra lazy. Because lazy is good. And we're just going to punch a 1/4 inch hole through the center line of the diagonal that connects the diamond to the edge. I mean, again, it sounds more complicated than it is, but that's because we're talking about things that are inherently visual. Now, it is important to note, and I haven't seen a tool so far that allows me to change that, otherwise I would, that SolidWorks, either by default or by convention, uses the radius notation for circles. Now, this doesn't make a whole lot of difference, but for me, I'm accustomed to putting the diameter and and when I know I want to make a 1/2 inch hole, having to divide every value I want by 1/2 is kind of a pisser sometimes. So you'll notice that that time we did 4 bolt holes in a single thing. Then we're going to go extruded cut, again through all, and wham, we're done. And that's pretty much it. You may have seen me mention the fillet and chamfer options in the previous video. Essentially what this does is this just applies a rounding or beveling to the face or edge. So essentially here's what we're working with.
We're across the other side, 1760 also. So we'll always get you guys' stuff sometime. Okay, thank you.
So back to it. And then just select all the faces you want. And again, this is just to demonstrate. I'm not actually going to really do anything of purpose with this. So okay, SolidWorks didn't appear to like that. We'll just do it to one edge. Just. And it doesn't seem to like me right now. Let's see if we can do it. And that's a filter chamfer. It's basically a rounding of the edge. And again, these can really be applied to almost anything in SolidWorks. And a lot of times in videos, you almost see them being used as a placeholder to make something seem a lot more complicated than it actually is. But that's the general hang of it. Again, this was designed to be a quick video that's designed to teach you the basics, as well as give you some context. Alright guys, stay tuned for next set.